identity operator we need to discuss. So when we are comparing the object and when the values are inside the object are same and their memory location are same, then it will return true when we are using is operator. But if we are using is not, it will return false. It will return false if the object are not the object are not identity operator. Okay, like we can say if both the variables are not same object. So let me show you the for the example of this. Okay, suppose I don't want to I want to create a variable which store more than one value inside it. Okay, so this means we are creating a list. I will cover this list in the later session. I'm just taking an example for uh, this identity operator. So I'm creating a list. List means when we want to store multiple values of different data types into a single variable. Suppose I'm giving, uh, we can say my list. This is the name of our variable. And whenever
Mhm.
you are creating a list, you need to use square bracket. Okay.
Okay.
So suppose I'm giving one. This is my number data type element. We can say this is an element of this list having numerical data type. After comma, I'm giving another another element. Now I'm giving my name, Ravi. This is a string data type. Now I'm giving some decimal values, 2.34. And again, I'm giving some Boolean values. Boolean values means true or false, we can say. So whenever you are writing true and false, remember you need to write in a capital T or capital I. Okay. So this means we are creating a list. Okay.
Mhm.
Similarly, if I create another list, like my list one we can see. And I am copying everything and pasting here, copying everything. But now this time I'm using false. Okay.
Okay.
And
Mhm.
I'm creating another list two, which is equal to my list only. We are assigning my list to my list two. Okay.
Mhm.
Now suppose I want to check what is the memory location of this my list one and my list two. So we
Mhm.
have one function ID function. So inside the ID, I am giving my list one or my list comma ID, my list one and comma ID, my list two. Okay, I'm just running this thing. So if you see here, these values for my list and for my list two, both memory locations are same. But for my
Mhm.
list one, the memory location are different. Okay, so
Okay.
it means it means the memory locations are same and the values are same. Like if we are assigning this my list to my list two, it means the
Mm.
values are same. And if
Yes.
we are checking this, the memory location are same. It means these are same object. Okay. Now if I run this command print, if I'm checking like my list is my list, or we can say my list two is my list only. If I'm running this command, it will show true. Okay, because the values are same. Values are same. If I print this, suppose I print this my list two, you will see the same output here. If I print
Yeah.
if I print my list only, you will see the same list. So the values are same and the memory location are same. That's why this is showing true. Okay. But suppose I want to check this one. My list one is my list. So it will throw false because both having different values and both having different memory location. Okay.
Okay.
Sometime you use this command also like my list to double equal to my list. So remember, this is a comparison operator. Comparison operator always check the values only. If the values are same, it will return true. it will not check the memory location. Okay, suppose I change it to true only. Now you can say the values are same. Suppose these values are same. Okay, so if I check here my list 1 double equal to my list, so it will show true. But if I run this command, my list 1 is my list, it will show false. Instead of values are same, the locations, memory locations are different. Okay.
Okay. So
Yeah.
first one will take the memory locations and the second one will give the values preference. Okay.
Yeah. It will check only the values. But is will check both your values and your memory location both. Okay.
Mm-hmm.
Yeah. So this is how we can use identity operator. And if I'm using is not, it will do the reverse thing. Okay. It will do the
Okay.
reverse thing. Okay. Now moving to our bitwise operator. So we have already discussed bitwise operator, like bitwise operator doing the calculation on bitwise level. We can say on the binary level. So we have 6 type of bitwise operator. Ampersand symbol, we called it AND operator. It will check whether if each of the bit are 1, then it will return 1. Okay, so this is an example X ampersand Y. Similarly, we have OR. For that, we are using pipe symbol. Okay,
Mm-hmm.
so it means if any one of the bit is 1 or both of the bit are 1, it will return 1 in the output. Okay, I will show you in an example. Are you able to see this PDF, right?
Yeah, I can see.
Yeah. Okay.
Mm-hmm.
Suppose this is 45. It is a
Mm-hmm.
decimal number and I need to
Mm-hmm.
convert it into binary. So
Okay.
what I have to do, I need to divide it with 2.
Yes.
So the quotient will be 22 and the remainder will be 1. Okay.
Correct.
Now
Mm.
again, this 22, again I need to divide it with 2. It become 11 and remainder becomes 0.
Yeah.
Similarly, when I divide 11 with 2, it become 5. Quotient will be 5 and remainder will be 1. Okay.
Mm.
Similarly, if I divide 5 with 2, it become 2 and remainder will be 1. Similarly, when I divide 2 with 2, it become 1 and remainder will be 0. Make
Mm.
sure your quotient should be 0 at the end. Okay. So they take
Okay.
this 1 and divide with 2. The quotient will be 0 and remainder will be 1. Okay.
Okay.
So
Okay.
every time in the last, your quotient will be 0. Okay. Now
Mm-hmm.
what you have to do, the last the last line is your most significant bit. Okay, most
Mm.
significant bit means it is the bit which is at the left hand side. Okay,
Mm-hmm.
and sorry, right hand side. And this the first one is the least significant bit. It should be in the left hand side. This is your left hand side. See, this is your left hand side. Okay, and
Yes.
this one is your right hand side. So most
Yeah.
significant is showing the right hand side and least
Mm-hmm.
significant bit is showing the left hand side. Okay.
Mm-hmm.
So what you have to do, you have to just write this one come here, then 0 come here, then 1 come here, then this one come here. Okay. Similarly 0 and then 1. So this is the binary, we can say binary of this
For the
45.
45.
45.
Mm-hmm.
Okay. So this is the simplest way which you can use for converting decimal to binary. Now I'm going to reverse it. Like I'm converting from binary to decimal. Okay. I'm
Mm-hmm.
taking the same example like this one, 101101. Okay. So, and this 10 means whenever you are seeing this like 10, it means base 10. We are using base 10 for showing decimal number and base 2 for showing the binary number. Okay.
Mm-hmm.
So base 2 for binary number. So we have to convert binary to decimal. So whenever you are converting from binary to decimal, you need to multiply. Okay. It means
Mm-hmm.
you are going from lower base to higher base. When you are converting from lower to higher base, you have to multiply. When you are
Okay.
converting from higher base to lower base, you need to divide. Okay.
Okay.
So we need to like I have created this like a rectangle. We can say array. So here I have given 2 to the power 0. then 2 to the power 1, 2 to the power 2. Similarly, I have created a series. Okay. Now, what is the meaning of this 2 to the power 0? It means 1. 2 to the power 1 means 2. 2 to the power 2 means 4. Similarly, 8, 16, 32, 64, 128. Okay.
Yes.
Now, what you have to do, always move from right hand side. Okay. Never go from left hand side. Always move from right hand side. See, this one is here now. This one is here now. So this
Yes.
one multiply with this one. Okay. This zero, this zero, we have to multiply with this two. And this one will multiply with this 4. Similarly, this one
Mhm.
multiply with 8. And this 0 multiply with 16. And this one we have to multiply with 32. Okay. Then we need to add everything. Okay. So what will be the result? Let me show you. If I multiply the above one with 1, it becomes 1. If I multiply 2 with 0, it becomes 0. So 0. Similarly, 4
Mhm.
multiplied by 1, 8 multiplied by 1, 16 multiplied by 0, 32 multiplied by 1.
Okay.
So it becomes 32 plus 0 plus 8 plus 4 plus 0 plus 1. If you add everything, it becomes 45.
Okay.
Okay. So what you need to do whenever you are converting anything, you need to just remember this thing, this block. 1, 2, 4, 8, 16, 32, 64, 128. Okay. And you need to go from right hand to left hand side. Never go from left to right hand side.
Okay.
Okay. You need to multiply 1 with the respective, we can say bits. These are bits. Okay. And
Mhm.
then you need to add everything. Suppose we have binary number, we have bit 1 and we have bit 0. So when we do and, when we use and operator between this 1 and 0, it becomes 0. When we use the 0 and 1, it becomes 0. When we have bit 1 and 1, it becomes 1. So remember, whenever we have both of the bit 1, then only we will get 1 in case of and operator. Okay. If any is there is 0, it means overall result will be 0. Is it clear?
Okay. Okay.
Okay. Suppose
I
I
think
have
this
given,
topic is already discussed, right? You are just
yeah,
reviving it.
I'm just reminding everything. Okay.
Okay. Go ahead. Go ahead. No.
Yeah. Now I'm taking an example. Suppose A is our variable and here I have assigned A is equal to 5. B is equal to 3. So first we need to find this A and B, A ampersand B. So
Mhm.
here what you need to do, first you need to convert it into binary. So the binary conversion of 5 is 0101. You can directly if you remember this pattern 1, 2, 4, 8, 16. So you can directly add this. This is our 1 and this is our 2, this is our 4. So we have to add only this like 1 and 4, it become 5. We do not need to sum for this 0. Okay, let me
Okay.
let let me take a pencil then. 1,
We'll do it.
2, 4, 8,
8,
16.
16.
Okay, so what you
Mm.
need to do, this 1 multiply with 1, this 0 multiply with 0, this 1 multiply with this 4, and this 0 multiply with this 8. So what you will get when you multiply anything with 0, so it becomes 0. So I'm not
Mm.
taking this and this. Okay. So I'm just
Mm.
taking this one. 4, if I multiply 1 with 4, it becomes 4. And if I multiply 1 with 1, it becomes 1. So if I add 4 plus 1, it becomes 5.
Mhm.
Okay. So this is how you can like immediately convert any decimal to binary if it is a smaller number. Now
Okay.
is it
In the same way, let's do it for 3.
yeah, in the same way. So what we have to do, we need to multiply one with one, and this one with two. But here we have 4, and here we have 8. So if 0 we do not considering. So only with this one, this 2 we need to add. So 2 plus 1 means 2 plus 1. It means when we multiply 1 with 2, it becomes 2. When we multiply 1 with 1, it becomes 1. So overall result will be 2 plus 1. So it becomes 3.
Yeah, the outcome I understood, but how we have derived 0, 0, 1, 1? Can
Okay,
you go back
okay,
to the first slide, which we have
okay,
described?
okay, okay.
First slide we were described, right?
Mhm. So for that, we need to divide it. We divide it with 2. Okay.
Correct.
Yeah.
So 3/1 is three. Sorry, 3/2 is equal to
Remainder will be 1 and quotient will be 1. Okay. And again, let me write this. Let me write it. So if I divide 3 with 2, it remainder will be quotient will be 1. Okay, I'm just writing this. Quotient will be 1 and remainder will be 1. Okay.
mm,
Again, we need to divide 1 with 2. 1 with 2. Then quotient will be 0 and remainder will be 1. Okay. So this is your most significant bit and this is your least significant bit. Okay. So what you have to do, your binary language will be 1 1 1 only. Okay.
mm,
Okay. But we can use 0 before. We can use 0 anytime before in the left hand side. Okay. So I can use 0 before. Yeah, if suppose you have remembered, you have seen this thing like 34-bit, sorry, 32-bit and 64-bit. In our computer, we have this thing.
correct.
Okay. So what is happening here? This one digit is showing bit. Okay. So
Mm-hmm.
if you are, it means this is 4-bit. Sometime your compiler is 4-bit. So every time it is taking 4 digit. If it has only 2 1 in the, it means it has only 11. So it will automatically add 20 in the beginning. It become
Mm-hmm.
4-bit. Okay. Sometime your compiler or we can say interpreter or compiler is 8-bit. So that time your binary language will be look like this. This one. It means 8-bit. Okay. Sometime your we can say compiler is 16-bit. Okay. 8 and then 16. So this will be look like this.
Okay.
Okay. So this 0 will be any in the left hand side, you can add any 0. It depends on the compiler.
Mm-hmm.
So I'm just showing this for representation purpose. Okay.
Mm-hmm.
So this is also correct. This is also correct. This is also correct. So now we have converted this 5 into binary and this 3 into binary. Now what is the A ampersand B? It will, this is 1 and this is 1. So we have already seen if both the bits are 1, then the overall result will be 1. Now see here it is 0 and it is 1. If only one bit is 1, then it becomes 0 in case of AND. Similarly,
Okay.
this is also 0 and this is 0. Then then you need to convert it into decimal language. This is in binary now. You need to convert it into decimal language. So it will be like 2 to the power 0 only because of rest everything is 0. So 2 to the power 0 means 1. Suppose A is equal to 5, B is equal to 3. Now I'm printing just A ampersand B. Subtracted. See here it become 1. Okay.
Mm.
If you want like to check the binary language, there is a pre-built, we can say inbuilt function in Python. We called it bin. Okay. We called it bin.
Mm-hmm.
So if
Mm-hmm.
I'm giving here bin 3, bin A, and I'm printing this. So you will see like, don't see this 0B means you are converting it into binary.
Okay.
So the binary of this 5 will be 101. Okay. If you
Mm-hmm.
if you give here B, you will see 0B11. So this is the shortcut way we can see whether our calculation is correct or not. Now there is one more operator, or. Or means pipe symbol. Okay. So what the difference is here, when you are using or, it means when any of the bit is 1, then overall result will be 1. If you see 0 or 1, it means 1. 1 or 0 means 1. 0 0, it becomes 0 only. And 1 or 1 means 1. Okay. So it means If any of the bit is 1, then the result will be 1.
Yeah. Okay.
Now, what we have to do here, like here we can see, if you see here, 1 or 1, it become 1, 0 and 1 become 1, 1 and 1 become 1, and this 0, 0 becomes 0. Now, if you convert this into decimal language, so it means 2 to the power 0, or I'm just writing 2. I'm just writing 1, 2, and 4. Okay. So if you add everything together, it becomes 7.
Okay.
Now we are going to see XOR operator. This one, XOR operator. XOR operator means when any one bit is 1, then only overall result will be 1. Otherwise, it will be 0. So if you see here 0 XOR 1, it means 1. 1 XOR 0, it means 1. 0 XOR 0 means 0. 1 XOR 1, it means 0. Okay.
Hmm.
So this is the basic logic. Now I have like taken 5 and 7. Okay. And I'm converting A is or B. So that the decimal of this 5 is 101 and 7 is 111. Okay. So if you see here, 1 and 1 become 0 in case of jaw. 0 and 1 become 1, and again 1 and 1 become 0, and 0 and 0 become 0. So
Yeah.
overall result will be, if you write the binary 2 and 0. So in this place you have 0. So if you multiply 0 with 1, it is also become 0. Okay. So only 2 is left. So your overall result will be 2. Now we have this not operator. Okay. So not operator, let me first tell you the formula. Suppose we need to convert, and remember one thing, whenever you are using not operator, only one variable or only one value you need to, you can use only one variable or only one value. Not of n, it become minus of n plus 1. Okay, let me show you an example. Suppose this is our decimal number 0, and we are doing the not of this 0. So it become minus 1. 0 plus 1, and it become minus 1. Suppose we have 1, then the not of 1, this is our we can say this is our decimal number. So it become 1 plus 1, minus 2. Similarly, if I am giving minus 3, it become, see here, this is negative number. So what you
Hmm.
have to do, minus 3 plus 1. So it become minus 2, and minus minus will become 2. Okay. Let
Okay.
me show everything
Yeah,
in here.
understood. Understood, man.
Okay.
Where do we use this, man?
Yeah, yeah, we
Where
will
do
do
we
here
use
in the,
this, man?
we will do
Yeah.
everything in the program. Okay.
Oh, is it?
So,
Okay.
yeah. Suppose I need to print this. A pipe symbol B. Okay. A pipe symbol B. So you will get 7. We have already seen 7.
Hmm.
Yeah, see here 7. Okay.
Yeah.
If I print here A or B, it becomes 6. Okay. We have used different number. We have used A is equal to 5 and B is equal to 7.
Hmm.
Okay. Now it becomes 2.
Yeah.
Okay. And one more thing, whenever you have, like, suppose I have assigned here B is equal to 3, but again
Correct.
I am assigning B is equal to 7. So it will take this
The
value, the
latest one.
latest one. Okay.
Okay.
And so whenever you are working in the Jupyter notebook, na, suppose I run this code, I have recently run this cell. So now if I am printing here, na, even I have written this in line 10, still it will take this 3. This B is equal to 3.
Is it? Oh.
Yeah, yeah, let me show. See, now we are checking the not operator. So suppose I am giving the not of A. Not of A means not of 5. So it become
Okay.
minus 6. Okay. Similarly, if I give here not of B, it become minus 8. And suppose I am giving some minor a negative number. So I am giving suppose minus 100, minus 1110. So it
It
becomes,
is taking the value of b is equal to 7, right?
yeah, b is equal to 7. B is our variable, no? And
Yeah,
inside
yeah.
that
The
variable,
recent,
we have 7.
yeah, it might ran recently. That is the reason it is taking.
Yeah, yeah.
Okay.
So if
For example,
we can,
let's do one thing. Let's do one thing. Run the code, scroll up slightly.
Mhm.
Yeah, run the level 13th line. Run the 13th line.
Okay,
No, it's 18, right? Sorry, 19, right? Yeah, run it.
it become 20.
Okay, okay. So now the b value will become 3, right? So run
Yeah,
18 now. Sorry, run 17 now.
yeah, -4.
Value changed, right?
Yeah, value change.
So it is taking the value of the b, whichever it is there in the 20th line.
Yeah, the recent cell values. The
Yeah,
recent
sorry. I just want to cross it. Okay. It's okay. Good.
now we have seen the not, we have seen the not operator, XOR operator. Now the most two important thing and very confusing, left shift and right shift. Okay. Uh, See this formula. This is like basic formula. When you don't have any time, when you don't have the time to calculate everything, remember this. Whenever you see this A left shift B, the formula will be A multiplied by 2 to the power B in case of left shift. Okay, and this will give you the decimal number. You do not need to convert from binary to decimal. Now we will see everything one by one.
Okay.
Suppose A is equal to 17 in the decimal form and B is equal to 2. Okay, so the binary language of 17 is 10001. Okay,
Okay.
and what this B is equal to 2 means you are shifting left hand side by 2 bit. Okay, so what is happening here? See, this one will move two side backward, means to the left hand side. Okay, this is our left hand side, this is our right hand side. So this
Correct.
one will move to the left hand side. Okay, similarly, this 0 will move two back hand side. And again, this 0 will move to back inside. And this 0 is also move to this blank side. Okay. And
Mhm.
this 1 is also moved at this blank side. So in case of left now, what you have to do, we need to we need to put here blank spaces, two blank spaces, because we are shifting 2 bit left hand side. Okay. So
Mhm.
remember, this is our left hand side and this is our right hand side. This is our right hand
Okay.
side. Okay.
Okay.
So we have to move in the left hand side. So when we
Okay.
move this one and we suppose I'm moving everything 2 bit left hand side. So you need to write like this 10001 and two spaces become blank. Your two spaces become blank. Okay. In the right hand side, your two spaces will be blank. Now you need to fill this blank with 0. Okay. Now if you convert this thing like this binary into decimal, your number will be different. Your decimal number will be different. Okay.
Yeah.
Now
Clear.
see, now you need to like 64 add with 4. It becomes 68. Okay. Rest are 0, then you need to multiply. So your overall result will be 68. Is it clear?
Yeah.
Yeah. Now you can do this thing by using this formula. This formula. This is the shortcut way. Suppose we have 17 and we are moving 2 bit left hand side. So 2 to the power 2 means 4. And when you multiply 17 with 4, the same result you will get 68. I'm taking the same example and I'm using K. A is equal to 17. B is equal to 2. Okay. Now I'm printing A left shift B. A left shift. Sorry, B. This one is B. So you will see the result is 68. Now, yeah, now we are moving for right shift. Okay. Right in case of right shift, we have this shortcut formula, but you need to divide A divided by 2 to the power B. If we are like we are using A right shift B, then the formula is A divided by
Instead
2.
of multiplication, we are doing dividing. We are
Yeah, we are
dividing.
dividing. Then same thing we are doing, like we have 17, we are like we are shifting in the right hand side. So what you have to do this time, you are moving everything in the right hand side direction. Yeah, this is our binary number we can say. So if we are moving in the right hand side direction, we need to exclude it. Okay. Suppose I'm moving this into this bit to 2 bit in the right hand side. So you will get these 2 bits. You do not need to include this 2 bit in the overall result. Okay. Then your result will look like this. If you see here, your result will look like this 0, 0, 1, 0, 0. You excluded this right hand side 0 and 1. When you are moving, remember, when you are moving left hand direction, then you need to put 0 in the right hand side in case of left shift. But in case of right shift, when you are moving all the bit in the right hand direction, you need to exclude all the bit of right hand side and you need to fill the 0 in the left hand side. Okay.
Got it.
So you suppose we have 17 and we are right shifting it by 2 bit. So you can write this formula 17 divided by 2 and you need to use 2 to the power 2. So it will be like 17 divided by 4. So if you calculate this, you will get the result like 4.25. Okay. So
Mm.
you do not need to take the decimal part. You just, your answer will be 4 only. See
Okay.
here, your answer will be 4. Okay. And if suppose I am shifting only 1 bit. I'm shifting only 1 bit. So it becomes 2 to the power 1. So you need to divide 17 with 2. Then your result will be like 8, 8.5. So your result will be 8 only. Okay. Let me show you the integers. Uh, I am doing for this one only. So I'm just printing A right shift P. And here P is equal to 1. So you
Yeah.
will see A. Okay.
Okay.
And if I do here 2, and I'm running this also. So it becomes 2. Okay. So remember one thing, whenever you are doing right shift, your value will decrease. And when you are moving left shift, when you are doing left shift, your value will increase. 17 increased to 68 in case of left shift. But here you can see 17 reduced to 4 in right shift.
Okay. Okay.
Okay.